Hello and welcome to week 9's lab exercise video. After completing this lab, you'll be able to develop your own generic classes in Java and apply data types of collections in examples, so programs that you write yourself. You'll analyze the properties of data types and perform experiments to test the performance of data types. Remember, it's important to choose the correct data type depending on your application. So as usual, you can go ahead and get started in Eclipse here by going and creating a new Java project. Let's call it Week 9 Lab. Finish. And we're going to start here with exercise section 2, generic classes. So all we want to do here is develop a simple generic class, and we're going to create a basic kind of data type box that will store an object whose type is parameterized by the symbol t and is closed within angular brackets. So we're going to write a generic class box with this class declaration. So we can do that quite easily. We go to File, New, and Class, and we can type in box here like that. And that's fine. All we need to do is add the parameter t. So t is going to be a parameter to our class. And when we write this, private t contents, then we're storing some element of type t. Now the next bit of this exercise is to define get and set methods for the instance variable contents, and a constructor method with a single input parameter to set the instance variable. And then we write a toString method which returns the string representation of the content of the box. So that's quite simple. Public void set contents, and we give it some contents here. This dot contents is equal to contents like so, and similarly t get contents, no input to that, and then just return this dot contents. Now you'll notice t is not actually a defined class. We don't have a class called t. T is a parameter, and we have a class parameter here, t, and it's indicated by these angular brackets. Of course, we can have multiple parameters like so, but we don't really need that. We just simply need one parameter here. And lastly, we can create a constructor box with an input parameter for contents, and we can set the contents to the value that we obtain here. So let's test this out. Let's make a new class here to test it. We'll call it box test. We create a public static void main method here, and we want to create a couple of different types of boxes. Before we do that, of course, I almost forgot. Let's go back here and write a toString method. So how do we do that? That's quite straightforward. String toString, and we just call this dot contents toString, because of course, whoops, and we return that because of course every object implements a toString method. There's a toString method in the object class that just simply returns the object type and the address in heap memory. So we can do that, and this makes sense. So let's just write a main method, and we're going to test out our box class. So we can do that. If you want, we can cut and paste a couple of things here and have a look and see what this does. Like this. So here we're creating box integer. So the box is going to store an integer, and it's a new box integer, and I give it the value 2. Now remember, because of auto-boxing, what this really means is this is not a primitive data type, but in fact it's that. But because of auto-boxing and unboxing, Java will simply reduce it we can write that, and Java will simply put the constructor call here. So we can do that. So if we just run this code like so, go to run as Java app, then unsurprisingly we create two box objects with type integer, and then we add the contents of the box by calling a.getContents and b.getContents. So that was pretty easy. What about this? We can create new local variables of box whose contents are of type double, string, and box integer. So let's try that. Like so. Or E. We can get a bit fancy and say, well, it's going to actually be the constant E in the math class. Of course we can do that. And we can, again, call box. Well, we could just simply, like we did before, D plus E, print that out. So we get a decimal number here. Now, something that I don't mention in the assignment, what we could also do is say box number, a box. Now that can store any number. So what do I mean by that? Remember from today's lecture, number is an abstract class, and every numerical wrapper class like double, integer, short, float, etc., they all inherit from number. So I can write something like this. Like so. So I can store integers here because an integer is a number, or I might want to store a double because, whoops, a double is a number. Remember, it has that extends relationship, or a subclass relationship. And of course, if I wanted to, I could always output these values. But wait, there's a problem. The operator plus is undefined for the argument types java.lang.number. So we can store these values, but because the plus operator is not defined on the numbers class, we can't unfortunately add them together. We would actually have to cast them. So there are limitations to this. This is very generalized code that we could use to store many different types of numbers, but we start to have problems whenever we try to write code that assumes a very specific type of value. So getting back to the task at hand, we can create a new local variable of box of type string, and unsurprisingly this is just like this. And we give it an input value like hello world. Maybe give that a better name, box string. So whenever we print this, this is basically calling toString, and of course it calls the string toString, and it prints out hello world. And lastly, we can also make a box of a box. We can make the box store a box, like so. Oops. So this box stores a box. Don't get confused. It's almost like recursion. Let's see if I can get this just right. It gets a little bit tricky with the syntax here. So I have to give it a new box that stores an integer, and that's going to give it a new integer, let's say 100. Whew. Okay, I think we've got it. Let's do a system.out.println. Now I would like to see what's inside this box, so I would say we remove all of this and just do a debugging, and let's see what's really happening here. Alright, so I'm going to press F6 and I get a box, and the contents are a box, and that contents is an integer. So pretty unsurprising. And so whenever I call a box.toString, which is what I'm doing here in this system.out, then it asks box integer to print itself out, which in turn asks the integer to print itself out. So that's pretty much it for the first for this exercise here. So I encourage you to play around with this a little bit and find out what you can and cannot do with generic classes. So generic classes are really good for writing very generalized code until you start needing something in particular, some sort of operation on a particular data type. So that's all for today, and I'll see you in the labs. Thanks very much. Bye.